Hello dear students, all of you welcome to Vidyan classes. It is the third lecture on functions in the chapter relations and functions. Today we will discuss some important functions in class 11 which are used in class 12. First, absolute value function or modulus function or numerical value function, or shortly it is read as mod function. What is the definition of a modulus function? Definition: fx is equal to mod of gx, which is equal to gx if gx greater than or equal to 0, minus gx if gx less than 0. If gx is 0 or positive, then mod of gx is equal to gx. If gx less than 0, then mod of gx is equal to minus gx. That means if it is positive or 0, then the result will be gx. If it is negative, its value is minus gx. It is denoted by star. Let gx is equal to x, which implies fx is equal to mod of x. Gx is taken as x, which is same as gx is equal to x. Gx is equal to x. Gx is equal to x. It is minus x. If gx means x greater than or equal to 0. Gx is less than 0. That means if x is less than 0. In general, it is the definition of a modulus function. In a particular case, mod of x is equal to x if x greater than or equal to 0, minus x if x less than 0. Clear? Example: mod of 2. If x is positive, then its value is equal to x. Here it is 2. Since 2 is positive, its value is 2. Mod of minus 2. Minus 2 is negative. If x is negative, that means less than 0. Its result will be minus x, which is same as minus of minus 2, which is equal to 2. If it is 0, if x is equal to 0, if x equal to 0, then its value is 0. The value of modulus function is 0 or positive. The value of mod function is 0 or positive. If it is positive, then its result will be that number. If it is negative, its result will be negative of that number. If it is 0, its value will be 0. The value of a mod function is 0 or positive. Graph of fx is equal to mod of x. Fx is equal to x, that means y. Y is equal to x if x greater than or equal to 0. Y is equal to minus x if x less than 0. y is equal to x. If x greater than equal to 0, y is equal to minus x. If x is less than 0. Clear? Y is equal to x if x greater than equal to 0. Y is equal to minus x if x less than y is equal to minus x if x less than 0. It is the graph of fx equal to x mod. Let gx is equal to minus x. Star implies this. Star means this definition is taken as a star. Let gx is equal to minus x. Gx, so mod of minus x, gx is taken as minus x. Gx is minus x. Gx is minus x, that is minus of minus x. If x, gx is x, x greater than equal to 0. If gx means that is equal to minus x. Minus x less than 0. Which is same as minus x if minus x greater than equal to 0, x less than or equal to 0. Multiplying negative sign, both the sides, minus of minus, that is x, greater than will be less than, so it is x less than equal to 0. And x, if minus x less than 0, implies this, x greater than 0. Multiply negative side, both the sides, it gives x greater than 0. X greater than 0, mod of minus x is equal to x. Here, x greater than 0, mod of x is equal to x. X less than 0, the result is minus x. Mod of minus x is minus x. X less than 0, mod of x is equal to minus x. X equal to 0. X equal to 0, the value is 0. X equal to 0, the value is minus 0. Minus 0 is same as 0. Therefore, mod of x is equal to mod of minus x for all x belongs to R. It is one of the properties of a modulus function. Let gx is equal to x minus 1. Star implies s. Star means this statement is taken as star. Mod of x minus 1. Gx is taken as x minus 1. It is 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 also x minus 1. X minus 1 if x minus 1 greater than equal to 0. Minus of x minus 1 if x minus 1 less than 0. Which is same as x minus 1 if x greater than equal to 1. Minus of x minus 1 if x less than 1. X minus 1 less than 0, x less than 1. It is the general form of modulus function. If gx is equal to x, then it is the modulus of x and given by this. If gx is minus x, Mod of minus x is defined as minus x if x less than equal to 0 and x if x greater than 0. If gx is taken as x minus 1, mod of x minus 1 is equal to x minus 1, mod of x minus 1, x minus 1 if x minus 1 greater than 0, minus of x minus 1 if x minus 1 less than 0. Similarly, let gx is equal to 2x minus 1. Star implies mod of 2x minus 1 is equal to 2x minus 1 if gx is taken as 2x minus 1. 2x minus 1 greater than equal to 0 minus of 2x minus 1 if 2x minus 1 less than 0, which is same as 2x minus 1, 2x minus 1 greater than equal to 0, that means x greater than equal to half, minus of 2x minus 1 if 2x minus 1 less than 0, x less than half. Clear? Next, properties of a modulus function. Let x, y, z be three real numbers. X, y, z belongs to R. Property number 1. X mod is the same as mod of minus x. Property number 2. X mod greater than equal to x, where x is the real number. X mod greater than equal to minus x. Property number 3. Mod of x plus y less than equal to mod of x plus mod of y. Property number 4. Replacing minus y for y. The left hand side will be mod of x minus y less than equal to x mod plus mod of minus y is the same as y mod. Property number 5. Mod of x mod minus y mod whole mod. Mod of x mod minus y mod less than equal to mod of x minus y. Property number 6. Replacing minus y for y. Replacing minus y for y, which is same as replacing minus y for y. Mod of minus y is the same as mod of y. By these properties, less than equal to replacing minus y for y, so the left hand side minus of minus y, that is equal to plus y. Clear? These are the properties we have to remember. These properties to solve the problems. Most important properties. Property number 7. X mod is equal to maximum of x minus x. Property number 8. Square of x mod is the same as square of minus x mod is equal to s square. Property number 9. Mod of x into y is the same as mod of x into mod of y. Mod of x into y into z is equal to mod of x into mod of y into mod of z. Property number 10. Mod of x by y is equal to mod of x divided by mod of y, where the denominator not equal to 0, that means y not equal to 0. Property number 11. X mod less than equal to a, that implies x greater than equal to minus a less than equal to plus a. Clear? Property number 12. X mod greater than equal to a implies s. If x is positive, then mod of x is equal to x, that means x greater than equal to a. If x is negative, mod of x is equal to minus x greater than equal to a, or x less than equal to minus a. Minus x, if x is negative, mod of x is equal to minus x greater than equal to a, that means x less than equal to minus a. These are the properties of a modulus function. 13. X mod less than a, that implies x greater than minus a less than plus a. These are the most important properties on modulus function. We have to remember these properties to solve all the problems in class 12. Here x mod is equal to mod of minus x for every real number. X, y, z are the real numbers. X mod greater than equal to x if x greater than equal to x or greater than equal to minus. Mod of x plus y less than equal to mod of x plus mod of y. For putting minus y for y, the left hand side is the mod of x minus y less than equal to mod of minus y is the same as mod of y. Fifth, mod of x mod minus y mod is less than equal to mod of x minus y. Putting minus y for y, the left hand side is the mod of x mod minus mod of y less than equal to y is replaced by minus y, that is x mod of x plus y. Mod of x is equal to maximum of x and minus x. It has two values. X mod is equal to x if x greater than or equal to 0, and it is minus x if x less than 0. So the maximum value of x mod is taken as max of x and minus x. Mod of square of x mod is the same as square of mod of minus x, which is equal to s square. Modulus of xy is the same as modulus of x into modulus of y. Modulus of xyz is the same as mod of x, mod of y, mod of z. Mod of x by y is the same as mod of x divided by mod of y, where y not equal to 0. Mod of x less than equal to a, that implies x greater than equal to minus a, less than equal to plus a. Mod of x greater than equal to a implies x greater than a or x less than minus a. Mod of x less than a, that implies x greater than minus a, less than plus a. Most important properties. Note down. Next, draw the graph of the following functions. First, fx is equal to mod of 2x minus 1. By definition, if 2x minus 1 greater than or equal to 0, then its value is 2x minus 1. And its value is minus of 2x minus 1 if 2x minus 1 less than 0. 2x minus 1 if 2x minus 1 greater than equal to 0. Minus of 2x minus 1 if 2x minus 1 less than 0. By definition, if mod of gx is equal to gx if gx greater than equal to 0 and minus gx if gx less than 0, here gx is taken as 2x minus 1, which is same as 2x minus 1 if 2x minus 1 greater than equal to 0, that means x greater than equal to half. Minus of 2x minus 1, 2x minus 1 less than 0, that means x less than half. Y is equal to fx. It is the form of y equal to mx plus c. It is also the form of y equal to mx plus c. We have to draw the graph and its value is 0 at x equal to half. At x is equal to half, y equal to 0. Y is equal to mx plus c. The value of m is 2. Its slope is 2. And it is y is equal to 2x minus 1. M is equal to 2. That means tan theta is m is equal to 2. Which is equal to tan theta. Theta is equal to tan inverse 2. Tan inverse 2 is the inclination of the line y is equal to 2x minus 1 and it is its value is 0 at half. It is x in this side, x greater than equal to half. X less than half. Y is equal to minus 2x plus 1. Its slope is negative. M is equal to minus 2. Theta is equal to tan inverse minus 2. This angle is the tan inverse minus 2. It is an acute angle, it is a obtuse. Tan inverse, the slope of this is 2 and its slope is minus 2. And its inclination is tan inverse 2, its inclination is tan inverse 2. It is the graph of the function mod of 2x minus 1, where x belongs to R. Clear? Okay. Next, to fx is equal to mod of x plus mod of x minus 1. X belongs to R. It is 0 at x equal to 0. It is 0 at x equal to 1. It is 1. It is 0. There exist three intervals. X greater than equal to 1. What is the value of this? X greater than equal to 0. This interval is x greater than equal to 0 less than 1, and this interval x less than equal to 0 is equal to, if x greater than equal to 1, here x greater than 1, mod of x is equal to x if x is positive, so it is x. X greater than equal to 1, x minus 1 greater than equal to 0, so this value is x minus 1. Clear? Mod of x is equal to x if x is positive. Here x is positive. X greater than equal to 1, x minus 1 greater than equal to 0, so mod of this is equal to x minus 1. If x greater than equal to 0 less than 1, x is 0 or positive. This value is x is greater than equal to 0, so by definition x mod is equal to x. X less than 1, x minus 1 less than 0, that means x minus 1 is negative. X minus 1 is negative, so modulus of x minus 1 is minus of x minus 1. If x less than or less than 0, here equal to 0, less than 0. If x less than 0, x mod is minus x. If x less than 0, x minus 1 less than minus 1, that means negative, minus of x minus 1, which is same as 2x minus 1 if x greater than equal to 1. And x is cancelled, that is 1 if x greater than equal to 0 less than 1. And it is minus 2x plus 1 if x less than 0. Clear? Clear? So graph of the function. It is x-axis, x-axis, y-axis. X greater than equal to 1. X greater than equal to 1. This is y-axis. X greater than equal to 1. The slope is positive. It is 1, 0 point. And it is 0. Origin. X greater than equal to 1. X greater than equal to 1. Y is equal to 2x minus 1. X greater than equal to 0 less than 1. Its value is always a constant. So it is parallel to y-axis. Y is equal to 1. X greater than equal to 0 less than 1. And 2x minus 1 if x greater than 1, the slope is positive. This part is y is equal to 2x minus 2x minus 1. Its slope is positive. It is the graph of y is equal to this part, x greater than equal to 1, y is equal to 2x minus 1. Its slope is tan inverse, slope is 2 and inclination is tan inverse 2. X less than 0, this part is, this side is x greater than equal to 1. This interval is x greater than equal to 0, less than 1. X less than 0. It is y is equal to 2x minus 2x plus 1. Its slope is negative. So it is the graph of the function fx is equal to mod of x plus mod of x minus 1. X greater than equal to 1, y is equal to 2x minus. X greater than equal to 0, this interval. X greater than equal to 0, less than 1. In this interval, y is a constant, that is equal to 1. It is y is equal to 1. It is y is equal to 2x minus 1. It is y is equal to minus 2x plus 1. Clear? Clear? Okay. Third, fx is equal to x mod is equal to x if x greater than equal to 0 and minus x if x less than 0. It is the graph of the function is this. It is the graph of the function f is equal to x mod. But it is given by, but fx is equal to minus of x mod. It is the opposite of this. Here y is always positive. Here y is greater than equal to, here y is greater than equal to 0. X equal to 0, y equal to 0. It is always positive. This value is positive. This value is also positive. X less than 0, x negative, minus x positive. It is positive, it is also positive. But here y is less than 0 or equal to 0. It is the opposite of fx is equal to minus of mod of x. Is the opposite of mod of x. So y is here, y is positive, but here y is negative. So its graph is clear. For x greater than 0, x greater than 0, y is equal to x greater than 0, y is equal to x greater than equal to 0, y is equal to minus x. It is y is equal to minus x, and here it is y is equal to x. If x less than 0, x mod will be minus x, minus of minus x, that is plus x. So this part is y equal to minus x, this part is equal to y is equal to x. Here x less than 0, this side is x greater than 0. It is the graph of fx is equal to negative of x mod. It is the graph of fx equal to x mod. It is the graph of fx equal to minus of x mod. Here y is always positive or 0, here y is negative. Minus of x mod is the opposite of mod of x. Clear? Clear? Okay, note down. greatest integer function or bracketed function. Definition: y is equal to fx is equal to bracket of x. X belongs to real set is equal greatest integer function. Where x bracket is the greatest integer but not greater than x. Where x bracket is the greatest integer but not greater than x. That means x bracket always less than or equal to x. It is also true that x bracket less than equal to x and greater than x minus 1. It is also true that x bracket is greater than equal to minus 1, greater than x minus 1 and less than or equal to x. Y equal to fx is equal to bracket of x belongs to R is called the greatest integer function where x bracket is the greatest integer but not greater than x. That is, x bracket is always less than or equal to x. It is also satisfies the condition that is x bracket is greater than x minus 1 and less than or equal to x. Example: bracket of 2 is equal to 2. X bracket is the greatest integer but not greater than x. That means x bracket represent an integer. If x is an integer, its result will be x, that is integer. If x is not an integer, then its result will be its previous integer. 2 is an integer, so its bracket value is 2. 1.3. X takes value 1.3 is not an integer. It lies between 1 and 2, so its bracket value is 1. Its previous integer is 1. Minus 1.5. It is not an integer. Its previous integer is minus 2. 9 by 4. That means 2 point something. Greater than 2, less than 3. Its bracket value is 2. 0.99. It lies between 0 and 1. So it is not an integer. Its previous integer is 0. Bracket of minus 0.999. Its previous integer is minus 1. Since it lies between minus 1 and 0. Clear? Bracket of 2 is equal to 1.3 is 1 minus 1.5. Its previous integer is minus 2. 9 by 4, that is, it lies between 2 and greater than, it lies between 2 and 3. 2 point something. So its bracket value is 2. It lies between, it is not an integer. It lies between 0 and 1. So its bracket value is 0 and it lies between minus 1 and 0. So its bracket value is minus 1. Draw the graph of y is equal to fx is equal to x bracket, where x greater than equal to minus 2 less than 2. Draw the graph of this. It is x-axis. This is origin. We have to draw the graph y is equal to x bracket. One, two, three, four. 1, 2. Minus 1, minus 2, minus 3, minus 1, minus 2, and 2 minus 3. We have to draw in this interval. X greater than minus 2. X greater than equal to minus 2 less than minus 1 implies its bracket value is, if x lies between in this interval, its bracket value is minus 2. X greater than equal to minus 1 less than 0, its bracket value is minus 1. If x greater than equal to 0 less than 1 implies its bracket value is 0. X greater than equal to 1 less than 2, its bracket value is 1. X. So this, when x lies between minus 2 and minus, bracket value is minus 2. X greater than minus 2, in this interval, the bracket value is the left side is closed and the right side is open. When x equal to 1, minus 1, its bracket value is minus 1. In this interval, the value is minus 2. The left side is closed and the right side is opened. It is the symbol of open, it is the symbol of closed. When x greater than equal to 0 less than 1, its bracket value is 0. So it lies, the graph lies on x-axis. When x greater than 1 less than 2, its bracket value is 1. Clear? It is the graph of y is equal to fx is equal to bracket of x. When x lies between this interval, its bracket value is minus 2. When x lies between this interval, bracket value is minus 1. When x lies between 0 to 1, In this interval, the bracket value is 0. When x greater than equal to 1, less than 2, its bracket value is 1. It is the graph of the function. Note x bracket is discontinuous at minus 1, 0, 1, 2. That means at every integer point, x bracket is discontinuous. That means the graph breaks. X bracket is at x is equal to k. K belongs to Z set. X bracket is discontinuous at x is equal to k. K belongs to Z. From this figure, it is clear that x bracket is discontinuous at x equal to k. Clear? Clear? Okay, note down. Next question. Draw the graph of y is equal to bracket of 2x where x greater than equal to minus 2 less than 1. In the previous class, we have discussed x bracket is discontinuous at x is equal to k belongs to Z set. Here x is replaced by 2x. So that y equal to bracket of 2x will be discontinuous or the graph breaks at the point where 2x is an integer. 0, 1, 2, 3, minus 1, minus 2, minus 3, minus 4, minus 5, dot. If 2x is an integer, the function will be discontinuous, which implies yes, x is equal to 2x is equal to 0, x is equal to 0, 2x is equal to 1, x is equal to half, 2x is equal to 2, x is equal to 1. The maximum value of x is 1. 2x is equal to minus 1, x is equal to minus half, 2x is equal to minus 2, x is equal to minus 1, 2x is equal to minus 3, x is equal to minus 3 by 2, 2x is equal to minus 2, x is equal to minus 2. The minimum value is minus 2. At these points, bracket of 2x is discontinuous. We have to draw the graph. It is 0, 0, half, 1, minus half, minus half, minus 1, minus 3 by 2, minus 2. Clear? When x greater than equal to minus 2, x greater than equal to minus 2 less than minus 3 by 2. 2x is greater than equal to minus 4 less than minus 3, which implies yes, bracket of 2x is minus 4. It is minus 1, it is minus 2, it is minus 3, it is minus 4. When x lies between minus 2 to minus 3 by 2, its value is minus 4. This side is open, this side is closed. When x greater than minus 3 by 2 less than minus 1, 2x is greater than equal to minus 3 less than minus 2. So bracket of 2x is equal to minus 3. So in this interval, it is When x lies between this interval, the bracket value is minus 3. Similarly, when x lies between this, its bracket value will be minus 2. When x lies between minus up to 0, its bracket value will be minus 1. When x greater than equal to 0, less than half, 2x is greater than equal to 0, less than 1, bracket of implies 2x is equal to 0. In this interval, this side open, this side is closed. And when x greater than half, less than equal to 1, 2x is greater than equal to 1, less than 2, implies this bracket of 2x is equal to 1. It is 1. This side is open, this side is closed. When x lies between this interval, the value is minus 4. When x lies between this interval, the value is minus 3. When x lies between this interval, the value is minus 2. When the x lies between minus up to 0, its value is minus 1. In this interval, the value is 0. In this interval, the value is 0. It helps to find out the graph of this. So, the graph of the function y is equal to bracket of 2x is this. Clear? Okay, note down. Next question. Draw the graph of y is equal to fx is equal to bracket of 2x minus 1 where x greater than equal to minus 3 by 2 less than 1. Note, in the previous problem we have discussed x bracket is discontinuous at x equal to k belongs to z set, that means set of integer. In the last problem, we have discussed x bracket is discontinuous at every integer point. Here x is replaced by 2x minus 1. So the function will be discontinuous where 2x minus 1 is an integer. 2x minus 1 is an integer. That means 0, 1, 2, 3, minus 1, minus 2, minus 3, minus 4, minus 5, When 2x minus 1 is an integer, the function will be discontinuous. 2x minus 1 is equal to 0 implies x is equal to 2x minus 1 equal to 0, x is equal to half. 2x minus 1 is equal to 1, x is equal to 1. 2x minus 1 is equal to minus 1, x is equal to 0. 2x minus 1 is equal to minus 2, x is equal to minus half. 2x minus 1 is equal to minus 3, x is equal to minus 1. 2x minus 1 is equal to minus 4, x is equal to minus 3 by 2. X varies. 2x minus 1 is equal to 1, it is 1. The maximum value of x is 1 and minimum value, the maximum value is less than 1 and the minimum value is minus 3 by 2. We have to draw the graph when x varies minus x varies close bracket minus 3 by 2 open bracket 1. At these points the function is discontinuous. X is equal to 0, x is equal to half, x is equal to 1, x is equal to 1. It is 0. 0 minus half, minus 1, minus 3 by 2. It is minus 1, it is minus 2, minus 3, minus 4, minus 5. 1, 2, x is greater than equal to minus 3 by 2, less than minus 1. X greater than equal to minus 3 by 2, less than minus 1. Implies as 2x less than equal to minus 2 greater than equal to minus 3. Which implies as 2x minus 1 less than minus 3 greater than equal to minus 4. Which implies as bracket of 2x minus 1 is minus 4. When 2x minus 1 varies minus 4 to minus 3, its bracket value is minus 4. So it is minus 4. It is the graph of fx is equal to bracket of 2x minus 1 when x lies between minus 3 by 2 minus 1. Next, x greater than equal to minus 1 less than minus half. 2x greater than equal to minus 2 less than minus 1. 2x minus 1 less than minus 2 greater than equal to minus 3. Which implies as 2x minus 1 bracket is equal to minus 3. Bracket of 2x minus 1 is this minus 3. For all values in this interval is minus 3. Next, x greater than equal to minus half less than 0. 2x greater than equal to minus 1 less than 0. 2x minus 1 greater than equal to minus 2 less than minus 1. Which implies as 2x minus 1 bracket is equal to minus 2. This value is minus 2. Open bracket, it is a close bracket. Clear? Next, x greater than equal to 0 less than half. 2x is greater than equal to 0 less than 1. 2x minus 1 greater than equal to 0 minus 1 minus 1 less than 0. So bracket of 2x minus 1 is equal to minus 1. It is the graph of 2x bracket of 2x minus 1. When x greater than equal to 0, less than half. Next, x greater than equal to half, less than 1. 2x greater than equal to 1, less than 2. Clear? Two x minus 1, which implies 2x minus 1 greater than equal to 0, less than 1. Implies bracket of 2x minus 1 is equal to 0. It is the bracket value of 2x minus 1, that is 0. Clear? X greater than equal to 0, less than 1, 2x is greater than 0, less than 1, 2x minus 1 greater than minus 1, less than 0. So bracket of this is minus 1. Here x greater than equal to minus or less than 0, 2x is greater than minus 1 less than 0, 2x minus 1 greater than equal minus 2 less than minus 1, so bracket of 2x minus 1 minus 2. Clear? So it is the graph of fx is equal to bracket of 2x minus 1 when x greater than equal to minus 3 by 2 less than 1. The function is discontinuous at x equal to minus 3 by 2, minus 1, minus half, 0, 1. Bracket of 2x minus 1 is discontinuous. That means the graph breaks at the point where 2x minus 1 is an integer. Clear? Okay, note down. Next question. Draw the graph of bracket of s square where x greater than equal to minus 2 less than or equal to 2. Equal to s square is equal to 0, 1, 2, 3, 4, 5, 6, dot. X bracket is discontinuous at x equal to k, k belongs to z. Bracket of 2x minus 1 is discontinuous at x is equal to k, at 2x minus 1 is equal to k, k belongs to z set. We have discussed these two problems in the previous question. Now x is replaced by s square. So put s square is equal to 0, 1, 2, 3, 4, 5, 6. At which point the function is discontinuous. What is the graph of the function? Which implies x is equal to 0, x is equal to plus minus 1, x is equal to plus minus root 2, x is equal to plus minus root 3, and x is equal to plus or minus of 2. X is equal to 0, x is equal to 1, x is equal to root 2, x is equal to root 3, x is equal to 2. Since x less than or equal to 2, x is equal to minus 1, x is equal to minus root 2, x is equal to minus root 3, and x is equal to minus 2. It is 1, 2, 3, 4, and 5. Clear? S square is 0 at these points. S square equal to 0 at 0, x square is equal to 1, at plus minus 1 and so on. What is the graph of the function? X greater than minus 1 less than plus 1. If x greater than minus 1 less than plus 1 implies s square greater than equal to 0 less than 1, which implies bracket of s square is equal to 0. When x varies minus 1 to plus 1, that is x greater than minus 1 less than plus 1, the graph. The value of the function is 0 always. It is open bracket, it is also open bracket. For all x belongs to minus 1 to open bracket minus 1 to plus 1, the value is 0. Implies f is continuous. Continuous on open bracket minus 1 and plus 1. The function is continuous in this interval. Now, for x greater than 1, greater than equal to 1, less than root 2, which implies s square greater than equal to 1 less than 2, implies bracket of s square is equal to 1. Bracket of s square is equal to 1 in the interval x greater than equal to 1 less than root 2. X greater than equal to root 2 less than root 3, which implies s square greater than equal to 2 less than 3, which implies bracket of s square is equal to 2. It is the graph of the function in the interval x greater than equal to root 2 less than root 3. X greater than equal to root 3 less than 2 implies s square greater than equal to 3 less than 4. Bracket of s square is equal to 3. Clear? Next, x equal to 2. At x equal to 2, y is equal to 4. X equal to y is equal to 4. X equal to s square is equal to 4. Bracket of s square is equal to 4. Clear? Next, x greater than minus root 2 less than equal to minus 1, which implies s square is greater than equal to 1 less than 2. Bracket of s square is equal to 1. In this interval, at x equal to minus 1, the value is 1. Close bracket. Next, x greater than minus root 3 less than equal to minus root 2 implies s square is greater than equal to 2 less than 3. Bracket of s square is equal to 2. Here, when x varies in this interval, bracket of s square is equal to 2. Next, x greater than equal to minus root 3 less than 2. Less than x greater than equal to minus x greater than equal to minus x greater than equal to minus 2 greater than minus 2 less than equal to minus root 3 implies s square greater than equal to 3 less than 4. Bracket of s square is equal to 3. When x greater than minus 2 less than or equal to minus root 3, bracket of s square is equal to 3. So the value is E. Clear? In this interval, the value is 3. Next, x equal to minus 2. X equal to minus 2, y is equal to 4. X is equal to minus 2, y is equal to 4. Most important, this f is continuous on close bracket. Very, very important. Though 0 is an integer belongs to this. Note fx is equal to bracket of s square is continuous at on open bracket minus 1 to plus 1. Fx is continuous on this. At x equal to 0, most important. The function is continuous on this interval. The slope of the tangent to the curve at 0 is 0. Dx at origin 0 0 is equal to 0. Slope of the tangent to the curve at origin is 0. Dx represents slope of the tangent to the curve at origin. Also, dx is equal to 0 on minus 1 to plus 1. The function is continuous in this interval. It is the graph of the function. Slope of the tangent to the curve at 0 0 is also 0. In overall, dx equal to 0 on minus 1 to plus 1. Open bracket. Clear? Okay. Next, exponential function. What is the definition of exponential function? Y equal to fx is equal to a to the power x a greater than 0, a not equal to 1 and x belongs to R is the definition of logarithm function, sorry, exponential function. It is the definition of exponential function. Since a greater than 0, a not equal to 1, there exist two intervals for a. Here a is equal to 0, here a is equal to 1. A not equal to 1 and a greater than 0. So it is the interval for a greater than 0, less than 1. And in this interval, a greater than 1. Since a greater than 0, a not equal to 1, either a lies between 0 to 1, that means a greater than 0 less than 1, or a greater than 1. Case 1. Let a greater than 0 less than 1. Y is equal to a to the x for x is equal to 0 implies y is equal to a to the 0, that is equal to 1. A greater than 0 less than 1, that is a is equal to 1 by 2, or a is equal to 1 by 3, or a is equal to 2 by 5, etc. Y is equal to a to the x, which is the same as fx. X is equal to 1 implies y is equal to a to the 1, that is equal to a. X is equal to 2, y is equal to a square. Increase of x, y decreases since a greater than 0 less than 1. Suppose a is equal to half. It is 1, it is half, it is 1 by 4. Increase of x, y decreases. Clear? Okay. For x is equal to minus 1 implies y is equal to a to the minus 1, that is equal to 1 by a. X is equal to minus 2 implies y is equal to 1 by a square. Decrease of x, y increases since a greater than 0 less than 1. Suppose a is equal to half. It is 2. It is 1 by 1 by 4. 1 by 1 by 4, that is equal to 4. Decrease of x. Decrease of x. Y increases. Clear? Graph. Increase of x, y decreases. Since a is greater than 0 less than 1, x increases, y decreases. What is the graph of the function? At x equal to 0, y is equal to 1. Suppose a is equal to half or 1 by 3. It is a 0, 1. Y is equal to a to the power x. A greater than 0, less than 1. A greater than 0, less than 1. Increase of x, y decreases. Decrease of x, y increases. Case 2. A greater than 1. That is A is equal to 2, 3, 2.5, etc. Y is equal to a to the power x. X is equal to 0 implies yes, y is equal to 1. X is equal to 1. Y is equal to a. X is equal to 2 implies yes, y is equal to a square. A is greater than 1. Suppose A is equal to 1, 2, 4. That means increase of x. Increase of x, y increases. Clear? X is equal to minus 1 implies this y is equal to a to the power minus 1 equal to 1 by a. X is equal to minus 2, y is equal to 1 by a square. Decrease of x, y decreases. Suppose a is equal to 1 by 2, 1 by 4. So, decrease of x, y decreases. Increase of x, y increases. Decrease of x, y decreases. Where a greater than 1, suppose a is equal to 2, it is suppose 2, it is 1 by 2, it is 1 by 4. Decrease of x, y decreases. Graph. Increase of x, y increases. Decrease of x, y decreases. So, it is the graph of y is equal to a to the x, a greater than 1. This point is 0, 1. It is x-axis, y-axis. Increase of x, y increases. Increase of x, y increases. Decrease of x, y decreases. Properties. Fx is equal to a to the x. Fy is equal to a to the power y. Fx plus y is equal to Fx is equal to a to the x implies this. Fy is equal to a to the y. Fx plus y and is equal to a to the x plus y, which is equal to a to the x into a to the y, which is equal to a to the x is equal to fx, a to the y is equal to fy. Therefore, fx plus y is equal to fx into fy. It is one of the properties of exponential function. Second, fxy fx is equal to a to the power x, a to the power xy, which is same as a to the x y. What is a to the x? That is fx whole to the power y. Therefore, fxy is equal to fx whole to the power y. Third, dr, domain of r, domain of the function df is equal to r set of a real number. Range of f is equal to always positive. Here y is positive, here y is positive. Open bracket 0 to infinity. Domain is R set and range of f is positive real number. That is R plus is equal to R plus positive real number. Exponential function is always positive. Not value of exponential function value of exponential function is always positive. That means for all x belongs to R, fx is equal to a to the x greater than 0. It is always, exponential function is always positive. For all x belongs to R, fx is equal to a to the x which is greater than 0. So, the graph of the function is always above x-axis. Clear? Next, logarithm function. Definition. Y is equal to fx is equal to log x with base a, where a greater than 0, a not equal to 1 and x greater than 0 is called logarithm function. Y equal to fx which is equal to log x with base a, where a greater than 0, a not equal to 1 and x greater than 0, that means x is a positive real number, is called logarithm function. Since a greater than 0 and a not equal to 1, there exist two intervals for a. A is equal to 0, a is equal to 1. It is the interval for a greater than 0 less than 1. Here a greater than 1. Case 1, a greater than 0 less than 1. Also it is defined by, is called the logarithm function, where a greater than 0, a not equal to 1 and x greater than equal to logarithm function, y is equal to log x base a, that implies by x is equal to a to the power y. If y is equal to log x with base a, then we can write x is equal to a to the y. Y equal to fx is equal to log x which base a greater than 0, a not equal to 1 and x greater than 0 is equal to the logarithm function. Y is equal to log x which base a implies by x equal to a to the y. Since a greater than 0 not equal to 1, there exist two intervals for a greater than 0 less than 1 and a greater than 1. Case 1, a greater than 0 less than 1. That is a is equal to 1 by 2, 2 by 3, etc. Y is equal to log x base a. By definition, x is equal to a to the power y. For y is equal to 0 implies x equal to 1. Y is equal to 1, that implies x equal to a. Y is equal to 2, that implies x equal to a square. For increase of y, a is equal to 1 by 2. It is 1, it is 1 by 2, it is 1 by 4. For increase of y, x decreases. Clear? For y is equal to minus 1, x is equal to implies x is equal to 1 by a. X y is equal to minus 2 implies x is equal to 1 by a square. If a is equal to 1 by 2, then x equal it is 2, it is 4. Decrease of y, x increases. What is the graph? Y equal to 0, x equal to 1. Y equal to 0, x equal to 1. It is 1, 0. Increase of y, x decreases. X decreases. Decrease of y, x increases. It is the graph of y is equal to log x base a, where a greater than 0 less than 1. Clear? It is x axis and it is y axis. Case 2. A greater than 1, that is a is equal to 2, 3, 3.5, etc. Y is equal to log x base a, implies by x is equal to a to the power y. For y equal to 0, that implies x is equal to 1. For y is equal to 1, x is equal to 8. Y is equal to 2, that implies x is equal to a square. Increase of y, x is also increases since a is greater than 1. Increase of y, x increases. Y is equal to minus 1 implies x is equal to 1 by a. Y is equal to minus 2, x is equal to 1 by a square. That means decrease of y, x decreases since a is equal to, suppose a is equal to, it is 1 by 2, it is 1 by 4. Clear? Decrease of y, x decreases. Graph. X is always positive. It is 1 0. X is always positive. X dash, y dash. Y is equal to log x base a greater than 1. Increase of y, x increases. This distance 1. The distance increases, x increases. Decrease of y, x decreases. Gradually, x decreases. Increase of y, x increases. This distance is 1. Gradually increases this distance. Decrease of y, x decreases. It is the graph of y is equal to log x base a when a greater than 1. Clear? No doubt? Next, properties of a logarithm function. By definition, of a logarithm function, y is equal to log x base a greater than 0, a not equal to 1 and x greater than 0. By definition logarithm function, we have y is equal to log x with base a greater than 0, a not equal to 1 and x greater than 0. Since a greater than 0, a not equal to 1, there exist two intervals of a. To case 1, a greater than 1. We have discussed for a greater than 1, it is the graph of the function meet x-axis at 1 0 order pair. Y is equal to log x base a greater than 1. X greater than 0. In this interval, that means x greater than 0 less than 1, the value is negative. First point, y is equal to log x base a is negative in this interval when x greater than 0 less than 1. In this interval, that means x greater than 0 less than 1, the value is negative when x greater than 0 less than 1 and a greater than 1. At x equal to 1, the value is 0. Second point, at x equal to 1, y equal to 0. Y is equal to log x base a is equal to 0 at x is equal to 1. implies this y is equal to log of 1 base a is equal to 0, where a greater than 1. Is the second properties, property 1, property 2. It is the definition of a logarithm function. Third point, x greater than 1, the value is positive. Since y is above x axis, y is equal to log x base a greater than 0. That means positive. If x greater than 1, a greater than 1. In this interval, y is negative. When x greater than 0, less than 1, y is negative. At x equal to 1, y is equal to 0. And y is equal to log x with base a greater than 0, that means positive when x greater than 1 and a greater than 1. Fourth, domain of the function. Here x greater than 0. That means positive real number r plus. Domain of f is equal to r plus, that means positive real number. Fifth, the range. What is the range? Y increases to infinity in the positive direction of y-axis, also decreases to negative infinity. So range of f is equal to set of a real number. Set of a real number. Y ranges minus infinity to plus infinity. So range of f is equal to r. Sixth point, y is equal to log x base a is an increasing function. As x2 greater than x1 implies fx2 greater than fx1. That means strictly increasing. X increases, y increases. Y is equal to log x base a greater than 1. Y is equal to log x with base a greater than 1 is an increasing function. As y increases with the increase of x, by definition x2 greater than x1, that implies fx2 greater than fx1. That means strictly increasing. Case 2, 3. Case 2, a greater than 0, less than 1. We have discussed the graph of the function takes in this form. When a greater than 0, less than 1, y is equal to log x base a greater than 0, less than 1. and meet x-axis at 1 0. In this interval, first point a greater than 0 less than 1. First point y is equal to log x base a is greater than 0 when x greater than 0 less than 1. Less than 1. When x get in this interval y is positive, that means x greater than 0 less than 1. Second point, at x equal to 1, y is equal to is equal to 0 at x equal to 1. That is log 1 with base a. A means a greater than 0 less than 1 is equal to 0. Third point, y is equal to log x base a. When x greater than 1, the value of the logarithm function is negative. Since the graph below the x-axis, y is equal to log x less than 0 if x greater than 1. Where a greater than 0 less than 1. And a greater than 0 less than 1. Fourth point, domain of f, that is positive real number r plus. What is the range? Y ranges negative infinity to positive infinity. Range of f is equal to set of a real number. Sixth point, increase of x, y decreases. Y is equal to log x base a is a decreasing function as x2 greater than x1, that implies this fx2 less than fx1. As x increases, y decreases. So it is decreasing in this interval. Where a greater than 0 less than 1. Increase of x, y decreases. 4. Log mn base a is equal to log m plus log n with base a. A greater than 0, mn greater than 0. Fifth, log m by n with base a is equal to log m base a minus log n base a. A greater than 0, mn greater than 0. Sixth, log 1 by x base a is equal to, by the fifth properties, log 1 base a minus log x base a is equal to 0 minus log x base a is equal to minus log x base a. 7, log m to the n base a is equal to n log m with base a greater than 0, m greater than 0. 8, log m to the n base a is equal to n into log m base a. Log base e x, which is same as ln x, where e greater than 0, greater than 2, less than 3. 9, log x base e is taken as ln x, where e greater than 2, less than 3. E to the power ln x is equal to x. E to the ln x is equal to x. These are the properties. We have to remember these properties to solve the problems without proof. Proof is not necessary. We have to remember these properties. Clear? Clear? Next, even function. What is even function? A function fx is said to be an even function if f minus x is equal to fx. A function fx is said to be an even function if f minus x is equal to fx. For example, fx is equal to s square fx is equal to cos x, fx is equal to x into sin x, fx is equal to gx plus g minus x, fx is equal to s square divided by 1 plus x to the 4 s star are the even functions. In this way, we can write the even functions. The function fx is said to be even if f minus x is equal to fx. For example, we will test fourth bit. Fx is equal to gx plus g minus x implies as putting minus x for x, the right hand side will be g minus x, g of minus x that is equal to x, which is same as fx. Since fx is equal to gx plus g minus x, f minus x is equal to fx. Therefore, fx is equal to gx plus g minus x is an even function. Here, if f minus x is equal to fx, then the function is said to be an even function. Similarly, we can test the functions are even. Third bit, suppose we will test the third bit. Fx is equal to x into sin x, which implies as f minus x is equal to minus x into sin minus x. Putting minus x for x, putting minus x for x, putting minus x for x, which is same as x into sin x. Since sin minus x is equal to minus sin x. Sin minus x is equal to minus sin x. So this will be x sin x, which is equal to fx. X sin x is equal to fx. F minus x implies as f minus x is equal to fx. Therefore, fx is equal to x into sin x is an even function. Similarly, we can test the other functions as even. Clear? Next, odd function. A function fx is said to be an odd function if f minus x is equal to minus fx. For example, fx is equal to s cube, fx is equal to x into cos x, fx is equal to log base e 1 minus x divided by 1 plus x. Fourth, fx is equal to root over of 1 minus x plus s square minus 1 plus x plus s square s star are odd functions. Test. Suppose we will test fourth bit is an odd function. Fx is equal to root of 1 minus x plus s square minus root of 1 plus x plus s square, which implies f minus x. That means putting minus x for x. So the right side will be 1 minus of minus x, that is plus x, minus x whole square minus root of 1 minus x plus minus x square, which is same as square root of 1 plus x plus s square minus square root of 1 minus x plus s square. Taking minus as common, it gives 1 plus x plus s square root over minus of square root of 1 minus x plus s square 1 plus x plus s square, which is same as minus of this value is fx, this value is fx, so minus of fx implies f minus x is equal to minus fx is a, therefore fx is equal to square root of 1 minus x plus s square minus root of 1 plus x plus s square is an odd function. Similarly, we can test the other functions as odd function by this process. Clear? Okay. Note down. Next question. Prove that every function can be written as an even function and an odd function. Prove. Let fx be any function so that let fx be any function so that fx is equal to gx plus hx, where gx is equal to fx plus f minus x divided by 2 and hx is equal to fx minus f minus x divided by 2. It is equation 1. Gx and hx satisfies equation 1. Putting gx equal to this value and hx equal to this value in equation 1, which gives fx. Now we have to show fx is the sum of an even function and an odd function. Gx may be even or odd, hx may be even or odd. When gx is even, hx is odd. If gx is odd, then hx is even. Since fx is the sum of gx and hx, we have to show every function can be written as the sum of an even function and an odd function. Gx is equal to this value. G minus x is equal to, now Gx is equal to fx plus f minus x by 2. Putting minus x for x. G minus x is equal to f minus x plus f of minus x, that is equal to plus x divided by 2. Which is same as fx plus f minus x divided by 2, which is equal to gx. G minus x is equal to gx. It is the definition of an even function. Implies gx is equal to fx plus f minus x divided by 2 is an even function. H minus x, hx is given by fx minus f minus x divided by 2. Putting minus x for x, h minus x, f minus x minus of f of minus x, that is equal to x divided by 2, which is same as taking minus as common gives fx minus f minus x divided by 2, which is same as minus of this value is hx. Clear? Which implies h minus x is equal to minus hx. It is the definition of an odd function. That implies hx is equal to fx minus of f minus x divided by 2 is an odd function. Here fx is equal to gx plus hx, where gx is an even function and hx is an odd function whose sum is fx. Therefore, the statement is proved. Therefore, the statement is proved that true. Therefore, the statement is proved that true. fx is equal to gx plus hx. Most important, fx is equal to gx. What is the value of gx? fx plus f minus x divided by 2. Plus what is hx? fx minus of f minus x divided by 2. It is even, it is odd. It is the general formula to express a function as the sum of an even function and an odd function. Example, express e to the x plus sin x, express e to the x plus sin x as the sum of an even function and an odd function. Express e to the x plus sin x are the sum of an even function and an odd function. It is the general formula to express a function as the sum of an even function and an odd function. Let fx is equal to e to the x plus sin x, which implies f minus x is equal to x minus x is replaced by x. So the right hand side will be e to the power minus x. Sin minus x is equal to minus sin x. Since sin minus theta is equal to minus sin theta. Fx is equal to e to the x plus sin x. F minus x is equal to e to the minus x plus sin minus x, which is same as minus sin x. It is the general formula to express the given function as the sum of an even function and an odd function. Fx is equal to e to the x. Fx is equal to fx plus f minus x divided by 2 plus fx minus f minus x divided by 2, which is equal to fx means e to the x plus sin x plus f minus x means e to the power minus x minus sin x divided by 2 plus e to the x plus sin x minus of f minus x minus of f minus x, that is e to the power minus x plus sin x whole divided by fx is equal to e to the x plus sin x, f minus x is equal to e to the minus x minus sin x whole divided by 2. Fx is equal to e to the x plus sin x, f minus x is equal to minus f minus x means minus of e to the minus x plus of sin x. Sin x cancel, which is equal to e to the x plus e to the minus x divided by 2 plus e to the x e to the minus x sin x plus sin x 2 sin x by 2, that means sin x. E to the x minus e to the minus x divided by 2 sin x plus sin x, that is 2 sin x by 2, that is sin x. It is the answer. Fx is equal to e to the x plus sin x. It can be expressed as the sum of an even function. It is the even part, it is the odd part. It is the even part and it is the odd part. Clear? Clear? Okay, note down. Next, constant function. What is constant function? A function f so that a to b, a b are the subset of R, that is real set, is said to be a constant function A function f such that a to b, a b belongs to R is said to be a constant function if there exists a real number k such that fx is equal to k for all x belongs to a. It is the definition of constant function. That is a function f such that a to b, a b subset of R is said to be a constant function if there exists a real number k such that fx is equal to k for all x belongs to A. Implies this. What is the domain? Domain of f is equal to a set. X equal to 1, k is a constant, x equal to 1, value is k, x equal to 2, value is k, x equal to 3, value is k. That means the range is set of k. Range of f is equal to set of k. The domain is a set and the range is the set of k, where k is a real number. Or we can define f such that a to b is a function f such that a to b is said to be a constant function if its range is a single tone set. Single tone set means set having only one element. Set having only one element is called single tone set. The range is a single tone set. F such that a to b is said to be a constant function if its range is a single tone set. Or we can say f x1 is equal to k, f x2 is also k. For two elements x1, x2 belongs to A, f so that a to b is said to be a constant function if for any x1, x2 belongs to A implies this f x1 is equal to f x2. Since f x1 is equal to k, f x2 is equal to k. Clear? Example, fx is equal to 5 is a constant function. f1 is equal to 5, f2 is equal to 5, f3 is equal to 5, f5 is equal to 5 and so on. Graph. Y is equal to fx is equal to 5. Since f1 is equal to 5, f3 is equal to 5, f 4.5 is equal also 5. F minus 1 is equal to 5. F minus 3 by 2 is also 5. Constant function is parallel to y-axis. Note. Constant function is parallel to x-axis. Y is equal to 5. It is y is equal to 5. Constant function is parallel to x-axis. Again, fx is equal to k is a constant function. F minus x is also k. Fx is equal to k, f minus x is also k. Implies fx is equal to f minus x. It is the definition of even function. Therefore, constant function is an even function. Fx is equal to f minus x is equal to fx. It is the definition of even function. Constant function satisfies the definition of even function. Therefore, constant function is an even function. Its graph is parallel to x-axis. If k equal to 0, the graph is along x-axis. That means y equal to 0. Clear? Range is the singleton set. Or we can say f a to b is said to be a constant function if its range is a singleton set. Or we can define f such that a to b is said to be a constant function if for any x1 x2 belongs to a, fx1 is same as fx2. It is the example of a constant function. Constant function is parallel to x-axis. Constant function is an even function, since it satisfies the definition of a even function. Clear? Okay, note down.